I will be guiding you all to do exercise 1 for unit 8.2. So in this exercise, we will use Azure App Service deployment slot to create a safe and zero downtime deployment process for a social media web app. So in this exercise, we will deploy 2 different versions of the web app, one to the production slot and the other one is to the staging slot. This slot will allow us to test changes before going live. So first, we will create a web app in Azure portal. So in this basic app, we will just use the value that are stated in the unique VLE. So for the try a secure unique default hostname, we'll not turn that one on, because if you turn that one on, your URL will have like a unique value of number because you turn on the unique default hostname. If you turn it off, your URL will be just hungryrose.azurewebsite.net. If you turn it on, it will be like hungryrose345 azurewebsite.net. It will become unique like that. So the other is the same like in the VLE. And also for the application insight toggle, I will not turn it on because the application insight is more to like if you want to have a extensive analytic of your web application. If it's like if you want to see its performance or and etc., you can turn it on. But for this exercise, we do not need to use it, so I will turn it off. And then we'll validate the web app first. After that, we can create it. After the deployment is complete, we will configure the Git client and clone the web app source code. So we will use Azure Cloud Shell to do this. For this, we are using local Git as deployment source. So as you can see there, there's like some error, the SCM basic authentication partition. So I just need to turn that one on, and then the error is gone. You can continue as usual. As you can see, the local Git branch is master. This one need to be highlighted because the one that in the VLE are using min branch, so the one that I use here is master. I think this one is default because I didn't change anything. Therefore, in the code later, some code need to be updated to the according to this one, the branch master, or else the code will have error. So after the deployment is complete, username and password need to be entered, and this password we need to make a note about this one because we will use this one in the code later. So just put it somewhere in your note or something. Next, we will use Azure Cloud Shell to configure Git using the username and email, the previous setting. And then we will create a folder named demo app so that we can include the sample ASP.NET app from the GitHub inside this folder. Then you can clone the source for the web app and you can run the command. So next, we will configure a Git remote to deploy the app to production. Just enter the password in the setting before this, and then we are good to deploy the web app to production slot. For this one, we will encounter the error because we did not state the branch here. So I need to change the code a little bit. So this is the correct code git push production main master, because for this web app I don't have the main branch, so I need to state there that the deployment will be pushed to production in the master branch. Only then it will run, or else it will encounter the same error, because nothing is getting pushed into the into the master. So after that we can see in the browser there's the web application ASP.NET. So next we will create a new staging slot. We will repeat the same local GitHub setup for the staging slot, including creating a new username and password. So we will be using the same source, which is local git for deployment. For the staging, also the branch is master. There's no main, so I think it's the default one. So the local git, we need to enter the new username and password. Also, we need to take note for this one because we need to use it in the code later. Then we need to load it up because there's no URL there. Then we can set up the git to deploy the app to the staging slot. You can just bash it. Oh, this one because we are not in the demo app folder. So we can edit. Then we need to change the code. You need to find an index CSHTML to change the source code, and then you can see the changes later in the browser. So we will change the ASP.NET to web app version 2, and then we can save the changes the normal way. Then we need to commit the changes in Git and push it to the staging slot using Git push staging. But it will encounter the same error because the staging doesn't have the main branch. So since we are using the master branch, we need to state it in the code that we are using the master branch. So the same thing, Git push staging main master. Then enter the new password for staging slot. Then we need to wait. When it's done, we can view it in the browser tab. So that's it. Before this, we have like the ASP.NET in the browser tab, but right now we have the web app version 2 because we changed the source code before this, and you can see the changes here. So that's all from. Thank you.
Now I'm going to show you how to deploy a web apps using deployment slot in Azure. First, under setting, I select environments variables. Now under app setting, I click add. I'm add a new setting names environments_name with the value production. I make sure to tick the deployment slot setting checkbox so that it's only applied to this slot. Next, I add another setting called apps_versions, set the value to 1 and leave the slot setting unchecked. Once both are ready, I click apply to save the setting. I do the same for the staging slot but with the difference value. I add environments_name with the value staging and mark it as a slot specific settings. Then I add apps_version with the value 2, but this time I don't mark it as a slot settings. Once done, I click apply. Back in all resource, I open the production slot, then go to deployment slot on the left menu. I click swap. Here I confirm that I'm swapping staging with production. After the confirm, I click start swap to proceed. Once it's complete, I go to the overview page of the production slot and click browse, and there it is. Version 2 is now live in the production slot. I close the tab once confirms. On the staging slot, I go to the configuration page under the general settings tab. Here I enable auto swap, set the target to production and click save. Now let's deploy version 3 and watch auto swap in action. In Cloud Shell, I run the following based on the video. In the editor, I go view to home and open index.cshtml. I replace like the video I doing. Then I press Ctrl S to save. Back in Cloud Shell, I commit and push the changes. Once deployment is complete, I see the auto swap has been triggered. I return to the Azure portal, go to the overview pages of the production slot and click browse. Version 3 should be appear. I just go to deployment slot page again and perform another swap to bring version 2 back to the production. Once that done, I go to overview, click browse and confirm that version 2 is back live.
In this exercise, you will start by creating an app service plan and deploying a sample web app that provides a hotel reservation API. First, from the home page or bottom menu, click create a resource, then select web app under the web category and then click create. In the basic tabs, fill out the required field, choose your Azure subscription, create a new resource group called MEZLAN-skill and assign a unique name to your web app, such as your name holder system. Set the publish option to code, choose .NET Core 3.1 LTS for the runtime stack, and select Windows for the operating system. Leave the app service plan setting as default and then click review plus create and confirm the deployment by clicking create. After the web app has been created, click on the Cloud Shell icon in the top menu of the Azure portal. Next, navigate into the source folder using the command that I type, and then build the application with the .NET build. Then, prepare the web app for deployment by navigating to the hotel reservation system directory. Move into the website folder, compress the files, and deploy the zip site to your Azure web app using the command in this video below. Once deployed, test the API in your browser. You should see a JSON response with a sample reservation. Next, you will monitor the app's performance under simulated load. Return to the Cloud Shell and navigate to the test client folder. Open app.config using the command code app.config and this file replaces your website name with your actual web app name in the reservation service URI field and confirm that the number of clients is set to 100. Let's configure the task to stimulate 100 users concurrently making reservation and querying data. Save and close the file. Now, rebuild the test client with the .NET build. Make sure the framework is correctly set. Save and close the file and then run the test client using .NET Run. You will observe messages indicating that reservations are being made and fetched. Over time, responses will slow down and you will start seeing HTTP 408 timeout errors due to the system being overwhelmed. In the Azure portal, return to your web app and navigate to monitoring and then research for metric and then set the time range to the last 30 minutes at the following metrics: CPU time sum, HTTP server error sum, HTTP 4xx sum, and average response time average. Pin the chart to your dashboard and then let the client app run for about 5 minutes and observe the metric. You will likely see high response times, a large number of 4xx errors, and sign that the server is under strain. Without stopping the client app, go back to your web app setting and select scale out app service plan, increase the instance count to 5 and click save. This adds more compute resource to handle the increased load. And then switch back to Cloud Shell and continue monitoring. Over time, you should see a decrease in HTTP 4xx error and response time, and increase in CPU time due to the additional instances. Let it run for another 5 minutes to observe the improvement. Optionally, you can scale the instance count up to 10 to see further performance gains. 10 is the maximum allowed for the S1 pricing tier. After experimentation, first enter in Cloud Shell to stop the client app. Finally, you could return to the Azure portal and scale the instance count back down to 1 to conserve resources. This completes the manual scaling process, demonstrating how performance improves with additional resources and how Azure lets you adjust the capacity dynamically based on the need.
In this section, the hotel reservation system web app that was previously deployed will be scaled up. Select all resources, then navigate to your app service plan. Under settings, select scale up app service plan. The plan is set to S1, which offers 100 Azure compute units and 1.75 GB of memory running on an A series virtual machine. In the Cloud Shell, type cd mslearn hotel reservation system /src hotel reservation system test client. Run the client app by command .NET run. Let the system run for a few minutes. Then navigate to the chart displaying the web app metrics on the Azure portal dashboard. The statistics show relatively slow response time and a high number of HTTP 4xx errors. In the Azure portal, go back to the page for the app service plan. Under settings, select scale up app service plan. Choose the P2V2 pricing tier and click apply. After scaling up, wait for another 5 minutes, then check the performance chart on the dashboard in the Azure portal. Return to the Cloud Shell that's running the client app. Select enter to stop the app.